Hello students, in this video I am going to discuss some paragraph questions which have possibility to expect in the examination. I wish all the students to prepare well and crack in examination. Please like, share my videos. GVS Chem at 4093.
An organic compound with molecular formula C9H10O forms 2,4-DNP derivative, reduces Tollens reagent and undergoes Cannizzaro reaction. On vigorous oxidation, it gives benzene 1,2-dicarboxylic acid. Identify the compound and write equations for reactions involved. Now let us do this. In step 1, as molecular formula is C9H10O, it must be highly unsaturated. It may have a benzene ring. As it gives 2,4-DNP derivative, it must have a carbonyl group, that is C double bond O. As it reduces Tollens reagent, indicating that the carbonyl group present, it must be aldehyde group, that is C double bond OH. As it gives a Cannizzaro reaction, there should be no alpha hydrogen. On vigorous oxidation, as there is no alpha hydrogen, the CHO group must be connected to benzene ring directly. On vigorous oxidation, it gives benzene 1,2-dicarboxylic acid. That means the remaining 2 carbon atoms must be present on adjacent to CHO group on benzene ring. Therefore, satisfying all these conditions, the formula of the substance is represented as benzene C2H, CH3, CH2, CH3, CHO. The reactions are shown here. An amide with molecular formula C7H7ON undergoes Hoffman bromide degradation reaction to give an amine B. B on treatment with nitrous acid at 273 to 278 Kelvin forms C, which on treatment with chloroform and ethanolic potassium hydroxide forms D. C on treatment with ethanol gives E. Identify A, B, C, D and E and write the sequence of chemical equations. As we see the solution for this question, as the molecular formula is C7H7ON, it is highly unsaturated. Therefore, it must have a benzene ring. As the given substance is an amide, it must be a benzamide. A, that is benzamide, undergoes Hoffman bromide degradation, that is reaction with bromine and alkali, gives amine. In Hoffman bromide degradation, the amine formed has 1 carbon less than amide. So here aniline is formed. The substance B is aniline. C, that is aniline, on treatment with nitrous acid. Nitrous acid is obtained by the reaction of sodium nitrate and HCl. At 273 and 273 Kelvin, that is ice cold water, forms benzene disonium chloride, that is C6H5N2Cl. So the reaction is given here. C, that is benzene disonium chloride, on treatment with chloroform and ethanolic potassium hydroxide, that is alcoholic KOH, gives benzene isonitrile. This reaction is also called as a carbyl amine reaction, and this reaction is used to identify aniline primary amines from secondary and tertiary amines. C, that is benzene disonium chloride, on treatment with ethanol gives E. So E is benzene. Isonitrile, benzene isonitrile is D. So here in this question, A is benzamide, B is aniline, C is benzene diazonium chloride, D is benzene isonitrile, E is benzene. So the overall reaction is shown here. Now let us see another question. An organic compound X on treatment with ammonia gives Y, which on heating gives Z. Z when heated with bromine in the presence of KOH produces ethylamine. Identify X. As we discussed now, as the substance is treated with bromine and potassium hydroxide, that is alkali, produces an amine. That is, amine is up. This reaction is nothing but a Hoffman bromide reaction. In Hoffman bromide reaction, amide gives amine having one carbon less than amide. As product is ethylamine, the reactant must be propanamide, that is CH3CH2CONH2. This amide is obtained, amide is Y. This amide is Y is obtained from X by treatment with ammonia and on further heating X. Therefore, X must be an acid. So when acid is treated with ammonia, we get ammonium alkanoate. So here the acid is propanoic acid. Propanoic acid on treatment with ammonia, we get ammonium propanoate. Ammonium propanoate is heated, we get propanamide. Propanamide on treatment with bromine and KOH, that is Hoffman bromide degradation, we get ethylamine. Therefore, X must be propanoic acid. Question 4. An organic compound with molecular formula C6H6O forms 2,4-DNP derivative, reduces Tollens reagent. It does not give iodoform with sodium hydroxide and iodine. On oxidation, the compound gives an aliphatic acid. Identify the compound and write the equations for the reactions involved. As the molecular formula is C3H6O, that is number of hydrogen atoms is double the number of carbon atoms, it must be an aliphatic, that is open chain compound, and it is saturated. As the substance gives 2,4-DNP, the compound must have a carbonyl group, that is C double bond O. As it does not give iodoform, iodoform is CHI3. As it does not give iodoform with sodium hydroxide and iodine, the compound does not have methyl ketone. As the compound reduces Tollens reagent, it must have an aldehyde group. Therefore, satisfying all the conditions mentioned here, the compound must be propanaldehyde.
Now let us see next problem. An organic compound contains 69.77% of carbon, 11.63% of hydrogen and rest oxygen. The molecular mass of the compound is 86. It does not reduce Tollens reagent but forms an addition compound with sodium hydrogen sulfite and give positive iodoform test. On vigorous oxidation, it gives ethanoic and propanoic acid. Write the possible structure of the compound. Now here the molecular mass of the compound is 86. Now let us have a table in this element percentage composition. Multiply the percentage composition with molar mass and divide by 100. Therefore we get the mass of that particular element in the molecular mass. And divide this mass of the element in the molecular mass with atomic mass of the element. Therefore we can get the number of atoms in the empirical formula. Thus carbon has 69.77% and the mass of this element in the molecular mass is 60.22. By dividing with 12 we have 5 carbon atoms. Hydrogen percentage composition 11.63 and in the molecular mass its mass of hydrogen is 10.01. Therefore dividing with atomic mass of hydrogen 1, approximately it is 10 atoms in the empirical formula. And rest is oxygen. Oxygen percentage is 18.6. So multiplying with the molecular mass we get 15.996 Atomic mass of oxygen is 16. Dividing this 15.996 by 16, we get equal to approximately 1. Thus, the empirical formula has atoms as carbon 5 atoms, hydrogen 10 atoms, and oxygen 1 atom. Thus, the empirical formula is C5H10O. To get the exact formula of the compound, now we have the following steps. As the compound gives addition product with sodium bisulfite and positive iodoform test, iodoform is CHI3. As it gives positive iodoform, the substance must have methyl ketone. That is, it is not aldehyde, methyl ketone. This is methyl and of course this is ketone. This is methyl ketone total group. On vigorous oxidation, as it gives ethanoic acid and propanoic acid, the compound must have all 5 carbon atoms in the straight chain as shown here, and the carbonyl group is at second carbon. Therefore, the formula of the substance is pentan 2-one. So, in this compound, in this problem, the original substance is pentan 2-one. Now, let us have one more problem. An organic compound A with molecular formula C8H16O2 was hydrolyzed with dilute sulfuric acid to give a carboxylic acid B and an alcohol C. Oxidation of C with chromic acid produces B again. C on dehydration gives but1ene. Now we have to write the equations for the reactions involved and to find the original substance. Now, as C gives but1ene on dehydration, OH group must be present at the C1 carbon of the alcohol. So, alcohol on dehydration gives unsaturated hydrocarbon, that is alkene. So, it is a primary alcohol. Primary alcohol means alcohol group is at the first carbon. Primary alcohol, and the formula is CH3, CH2, CH2OH. Oxidation of alcohol gives acid. Thus, B must be CH3, CH2, CH2, COOH, that is butanoic acid. So, this B gives butanoic, oxidation of C gives, oxidation of alcohol gives B, and of course, from the original substance A, on hydrolysis we are getting B and C. One B is the original substance obtained from the substance A. As hydrolysis of the compound gives an acid and alcohol, the original substance must be an ester. Since the original substance has formula C8, C8 C8H C8H16, therefore the original substance must be butyl butanoate. This is the ester group. As hydrolysis products are carboxylic acid, this we discussed already. As hydrolysis products are carboxylic acid and alcohol, the reactant must be an ester. So, A, that is ester on hydrolysis with dilute acid, B is the carboxylic acid, and C is the alcohol. This C on oxidation we are getting a B, C on dehydration we are getting a alkene. Now let us see one more problem. Primary alkyl halide C4H9Br, that is A, reacted with alcoholic KOH to give compound B. Compound B is reacted with HBr to give C, which is an isomer of A. So C and A both are isomers. When A is reacted with sodium metal, it gives a compound D. That is, D is C8H18, which is different from the compound formed when N-butyl bromide is reacted with sodium. Give the structural formula of A and write equations for all the reactions. Now, the given substance is a primary alkyl halide, that is C4H9Br. This is A. Primary indicates a bromine atom is present at the C1 carbon atom of the chain. Alkyl halide on treatment with alcoholic KOH gives a dehydrohalogenated alkene. So we know that when alkyl halide on treatment with alcoholic KOH, it gives a hydrogen halide is removed and the product is alkene, that is HBr is removed and this alkene is B. This alkene B on addition of HBr gives C. So C is an isomer of A. As A is a primary alkyl halide, C must be either secondary or tertiary alcohol. When A is treated with sodium in the presence of dry ether, it gives a compound D. So this alkyl halide on treatment with sodium in the presence of dry ether, this is nothing but Woods reaction. So in the Woods reaction, when alkyl halide reacts with sodium in the presence of dry ether, we get an alkane with double the number of carbon atoms. So we get D as C8H18. So since A is a primary alkyl halide and A can have two possible structures, structure 1, structure 2. When structure 1, that is a compound A, reacts with alcoholic KOH, we get but1ene. When structure 2 reacts with, structure 2 is 2-methyl 1-bromopropane. When structure 2 reacts with alcoholic KOH, we get 2-methyl propene. When two structures, that is 3 and 4 of B, react with HBr again, the following substances are formed. When HBr is added to an unsaturated alkene, the addition takes place according to the Markovnikov's rule. So here Markovnikov's rule is involved. When structure 3, that is but1ene, reacts with HBr according to the Markovnikov's rule, we get 2-bromobutane. This is 2-bromobutane. So this is a secondary alkyl halide. Whereas structure 4, that is a compound B, reacts with HBr according to the Markovnikov's rule. Structure 4 reacts with HBr according to the Markovnikov's rule. Structure 4 is 2-methyl propene. When it reacts with HBr, we get 2-methyl 2-bromopropane. This is a tertiary alkyl halide. So this, let it be structure 5 and this is structure 6. Structure 5 is 2-bromobutane. Structure 6 is 2-bromo 2-methyl When structure 5 reacts with sodium metal, so this is Woods reaction. When structure 5 reacts with sodium metal in the presence of dry ether, we get 3,4-dimethylhexane. When structure 6 reacts with sodium metal in the presence of dry ether, we get 2,2,3,3-tetramethylbutane. So this substance is obtained from N-butyl bromide as it is given in the problem. Therefore, our substance must be 2-methyl 1-bromopropane. So 2-methyl 1-bromopropane reacts with alcoholic KOH, we get 2-methyl propene. 2-methyl propene on reaction with HBr, we get 2-methyl 2-bromopropane, which on reaction with sodium metal in the presence of dry ether, we get this product. Therefore, the original substance is 2-methyl 2-bromopropane.